Hello, I'm Bob DeCure, president of neuMedia Software and author of neuMedia Kiosk Video Booth Designer. This is a short tutorial on configuring overlay masks with neuMedia Kiosk. What you're seeing right now is the live kiosk screen with the current event configured for both photos and videos. So what are overlay masks? Quite simply, they are images placed on subjects' faces. For example, glasses. I'm not wearing any right now. What you're seeing is an overlay that can be changed with the click of a button. The default installation of neuMedia Kiosk comes with around 30 simple masks like these, but you can create your own and include them with any event. It's very quick and simple, yet a powerful feature included with the kiosk. By the way, this isn't my desk either. There, that's better. In the next video, we'll go over green screen setup. But for now, let's get started with overlay masks. This is the event configuration screen from the main menu. What you see at the top are different options in the tabs, and I'm on media capture. This area on the right is a preview of the kiosk window, which will show the effect of any changes that you make. The first thing in setting up masks that you have to do is to go to the capture device, and for video, select WebCam, the camera that you want to use, and this is the important part, the resolution. The masks are scaled from face to face, but the scaling is relative to the camera resolution. So it's best to pick a desired resolution, which is the default resolution of the camera, and stick with it. If you change the resolution of the camera, your scaling will be off and you'll have to reset the masks. Once they're set up with a certain resolution, however, they'll retain the configuration. So once let me take off the green screens. We just have a black background now, and I'm going to scale up so you'll better be able to see what I'm doing with the masks. So, at the bottom tabs for the media capture, we have the device, layout, which I just changed. I changed the background image with the scenery. We can take off the HLSL green screen. It's not needed anymore. And finally, we get to masks. By default, the mask overlays are disabled. Just toggle the button to enable the masks. Here are the list of the files that can be used for image masks. We can see a different view. If you want to add other ones that you've created, hit the Add button, and you can see the various masks that I've already included in the system. One thing to make note of are the file names. If you're going to group masks together for the guests, they should have the same file names for the groups, followed by 01, 02, 03, 04, etc. That way the grouping will be correct when the options are displayed to the guests. I've grouped together all of the glasses by name, and you can select the default just by highlighting it, and then click the back arrow to go back. Now we have a default mask, which is glasses 04. It's a transparent ping image. It's recommended that you use transparent images for the mask, although it's not necessary. Most transparencies are either ping images or GIF images. GIFs have the advantage of adding animation So if you want to do animated overlays, you can use animated GIFs for that purpose. Here's the fun part. The way that the masks work is by doing a face detection on the camera feed. This is done very quickly. Then once a face is detected, it extracts 70 features of the face so it can track the movement of the face. These are global defaults for face detection and feature extraction. For the most part, you don't have to adjust these, but you can adjust it to make the masks appear or respond faster to head movement, like I'm moving my head back and forth now. Here's how this works. I'm going to go into debug mode for masks. And what you can see are the timings. We've gone to black and white, and this is what the camera sees when it detects a face. The square around here, there'll be a square around every face detected, and these are what's called landmark positions of each face. There's a line drawn between the outer eyes, and this is how the angle of the mask is detected based on the angle of that line. The height of the mask is determined by the bridge of the nose to the tip of the nose. Now, once this is set up, you can adjust any individual mask by changing its height, and its width. Again, this is relative to the facial landmark positions of each face detected. By default, the image is positioned on the center of the bridge of the nose, but you can change the horizontal and vertical offsets for each image. And it doesn't matter the size of the face or where in the video feed the face is. Once it has detected the face, you can the image will scale. I'll give you an example. As I go closer, you'll notice that the glasses that I have for the image are also scaling up with the scale of the eyes. As I go back, they scale back down. These frame rates right here, and excuse me, I can barely see. I'm sustaining just under 50 frames per second. So I'm detecting faces at less than 5 milliseconds per frame. I'm doing the pattern detection at less than 2 milliseconds per frame. The capture, and I apologize if you can't see this on the video, but the capture is how fast the camera is feeding these images to the application. So I sum up these, I get the number of milliseconds per frame, and by that I can calculate the frames per second of the mask layout. If you are not detecting faces accurately, what you can do is adjust the minimum face size and the maximum face sizes. Right now I'm set up at 640 width on the screen. So the size of my face right now is about a quarter that, or about 200 pixels. I have the range of faces detected between 150 and 350 pixels. If I go far back in the photo and the faces are smaller, you can adjust this down and it will detect smaller faces. However, as you adjust this down and this goes up, the amount of time it takes to detect a face also goes up. So you want to keep the minimum face size as large as possible and still detect your subjects, and keep the maximum face size as small as possible for the same reason. So ranges of about 150 to 300 are good for most scenarios. The scaling also determines how accurate the face detection is. The higher the scale, the more faces it will detect. Sometimes faces are stacked upon themselves, and the scale is the number of pixels it goes across after it finds a face. So if you know that no two faces are going to be in the same frame, you can scale, you can put this all the way down to 1, and the face detection will be faster but less accurate. The number of neighbors also works in the same way. As you go higher, the slower the detection, but the more accurate face detection is. As you go lower, and you want to keep it as low as possible, the faster the detection is. Now, if you look closely at the mask, and let me go ahead and turn the mask off here so you can just see the facial landmarks. And I'm going to zoom in a little bit. If you'll notice, the point between the left eye and the right eye fluctuates as the facial landmarks are detected. The further away, or the lower the resolution that you have, the more this will fluctuate. The mask stabilization stabilizes the image as these points fluctuate. So you can say, don't change the image location unless it fluctuates above a certain threshold. And we'll just do another example of that. As I turn the stabilization off, you can see that the glasses are wobbling a bit. As I increase the but it reacts faster to my head movement. As I increase the stabilization, they've stopped wobbling, but it doesn't react as quickly to head movements. So these are global. The face detection defaults are global for all masks in all events. So once you have set this up with the camera resolution and got your face sizes, then you shouldn't have to set these anymore. And it doesn't matter how you scale the feed image. The mask will scale along with it. What matters is the camera resolution. The scaling, you can set that to anything that you want. Okay, we'll turn that off. Now for each mask in here, you can set the relative height, width, and vertical and horizontal offset. Now, some masks that I've set up have not been set. So here's an example of masks that have not had their default settings. They're just scaled to the center of the eyes and height of the nose at 100% and no offset. So what I'll do is, these are lips. I'm going to change the vertical offset so that they're on the lips, and change the width a bit, and perhaps the height, and make it higher or lower. There. You can do the same thing. I have a few hats that haven't been scaled. This is what they look like without the adjustment. Setting the height and width, vertical adjustment. There. Now we have a hat. When I turn the debug off, that's what the hat looks like in the frame. Again, the images that I have for the default masks are just samples. You can take any transparent image, any animated GIF, and create your own masks. You can take masks away by just highlighting them. Let's say this one, you can remove it, and now it no longer appears. Here's a Christmas hat. Setting the horizontal adjustment, make it a little bit wider, a little bit taller. And now we have a hat as a mask overlay. I'll save my changes. And now when we go back to the main kiosk window, when the system is active, and this is a preview of it, the masks will appear as they've been configured. And you can set them any way you want. I'm just playing around now. And that's it. Let's turn on a green screen effect. Add some scenery. And that's the setup for this event configuration. And that's it for the mask configuration. As I said before, in the next video we'll go over more detail on how to set up green screens.